Okay, today we're going to address lesson 13.2, which is in regards to circular functions. What we're going to talk today is kind of getting away from the idea of these functions as they relate to angle measure, and kind of talk about some other things that they can apply to. So there are many non-geometric uses of these trig functions. For instance, in this blue formula right here, it's y equals 2.5 times the sine of 0.03x. This actually will come fairly close to describing what is, let's see, what color do we want to do today? Let's go green. What is the shape of an ocean wave, which has an approximate height of y and a horizontal distance of that wave of x here. Another non-geometric use would be this formula right here, which describes the line voltage of an ordinary alternating current. So there are some applications here within the realm of electricity as well. So the question here is, do angles play a part in any of these? And of course that answer would be no. So these examples suggest that both sine and cosine, as it's used up here, can be defined with s, which will represent a number instead of an angle. Okay. Essentially what this is saying is we can use these trigonometric functions, sine, cosine, tangent, and their reciprocals to help us evaluate different formulas and whatnot. So let's get started here with this whole idea. Circular functions. We're going to let O be this circle right over here. Okay, so that's going to be O. And we're going to let that be the unit circle, which will be defined as x squared plus y squared equals 1. If you recall, that formula right there is the equation for a circle with a center at 0, 0, okay, and a radius of 1. Okay, we're going to let A be the point 1, 0, because since we have a radius of 1 here, that's going to be point A, so that point will be at 1, 0. And then we're going to it's going to be measured around this direction, okay? Given any real number s, we're going to start at A, and we're going to go follow in this direction, measure s units around circle O in a counterclockwise direction, okay? Now we're going to go counterclockwise, remember, if s is positive or it's greater than or equal to 0. And in a clockwise direction if s was less than 0 or if it's negative. Being less than 0 would be negative. And we're going to arrive at a point, we're going to define this point as point P, and we're going to name it XY. So that's going to be point P, which is going to be at XY. Okay. These circular functions, as we will call them, are going to be defined as follows here. Sine of s is going to be equal to, if you remember, it would be y over r, right? You remember sine being y over r? Well, in this case, what is our r value? Our r value is 1, right? We said that the radius of this circle is 1. Therefore, the sine would be y over 1, or simply y. Cosine would simply be x, because it would be x over 1, because we know r is 1 in this case. Now tangent of s, if you remember, is equal to the sine of s over the cosine of s, which, as we know right here, it's y over x. That should ring a bell. We should remember that. And now our reciprocal functions, of course, if sine of s is y, then cosecant would be 1 over y, and secant would be 1 over x, and cotangent would be the cosine of s over the sine of s, which is x over y. Okay. Now we're going to take a look at these drawings over here, these fancy drawings I've made. Circular function. Okay, so we're going to continue talking about circular functions of a number s. Okay, remember this s represents a number now. We're not talking about an angle. That's going to be equal to the corresponding trig function of any measure or of any angle with radian measure equal to s. So remember, when we gave those radians, we gave them in terms of theta. So theta is going to be a certain number of radians instead of degrees here when we're talking about radian mode. It's all related. It's just that when using these radians, we can apply these as numbers and not necessarily just angles, and we can use them for different things. Now, so these circular functions can be referred to as trig functions, and the context of the problem should make it clear whether we are referring to these circular functions using these radian measures, or if we're going back to our trig functions. Regardless, they are going to be the same. If you take a look at this drawing over here, we've got our point 1, 0, right? And we've got our arc S, which is the number that we're talking about. Well, that number is going to be the same as theta radians right here, because if you remember, you find this value here using theta and my radius. Well, if my radius is 1, then both theta and s are going to be the same. So let's look here. This sine, as we remember, sine is equal to y over r. We're just going to show you how we got to those numbers we got to up a little higher. So we know r in this case, is 1. Well, that's equal to y. Okay, which, as we set up there, was equal to the sine of some number s. And what I was just talking about with this relationship between arc length, theta, and the radius, we know that theta is equal to the arc length divided by the radius. Well, if the radius is 1, that's a pretty simple calculation. Theta will be equal to the arc length there, or s, that number value. Okay. Now, we're going to have our special triangles still here as well. So when we're thinking about these circular functions, when we have a radian measure that are multiples of pi over 6, which is 30 degrees, right? And pi over 4, which is the equivalent of 45 degrees, you'll remember that those are all of our special triangles, our 30, 60, 90 triangle, our 45, 45, 90 triangle. When they are multiples of these, we are going to typically use exact values for the trig functions unless a decimal approximation is requested. Okay, so just remember that if you are able to, and we'll go through an example a little later, if you're able to, we're going to use exact values there. Okay. So remember, the equation of this unit circle here that we talk about is going to be x squared plus y squared equals 1. By definition, we know that x is equal to the cosine of s, and y is equal to the sine of s. Therefore, if we do a little substitution, the cosine squared of s plus the sine squared of s will be equal to 1. Okay. Now we'll go do some examples. Hopefully that will clear up any confusion you might have up to this point. Okay. So for some number s, we've got a point -1/3 and 2 root 2 over 3. That is our x and y value, right? Our x and our y value. Okay. That is s units away from some point A, which is at 1, 0, along the unit circle. So let's sketch that out here real quick. We've got some point A right there. Whoops. That's 1, 0, right? And this is going to run along the unit circle. Okay. To some point -1/3 2 root 2 over 3. And the reason that I knew that it stopped over here in quadrant 2 is because of the coordinates right here. I have to go -1/3 and then up to root 2 over 3. Okay, so I know that that is my x value, that is my y value. We're just going to say it runs to this point right here. I don't know how exact that is. Okay. Find the exact values of the 6 circular functions of s. Well, if this is s right here, this arc length, the sine of s, as I remember, is simply equal to the y value of that point, right? So this is -1/3 2 root 2 over 3. Okay. So that's simply going to be 2 root 2 over 3. Quite simply, the cosine is going to be equal to -1/3. Now, the tangent is a little bit more complicated. The tangent is, as we know, the sine over the cosine, so y over x. So I'm going to write that out. I'm going to have 2 root 2 over 3, and that's going to be over -1/3. Now we remember, if we are dividing fractions, what we do is multiply by the reciprocal, right? So I end up with 2 root 2 over 3 times -3 over 1. And my 3's will simplify, and I will be equal to -2 root 2. That's all I'm left with, because my 3's simplified, right? Okay. So now my reciprocal functions are easy enough. I simply take the reciprocal of what I got for sine. So this would be 3 over 2 root 2, which I should know I need to rationalize that denominator by taking this times root 2 over root 2. Simplify here, right? So I'm going to have 3 root 2 over root 2 times root 2 would be 2, and then that 2 times that 2 would be 4. So I have 3 root 2 over 4. Now the secant is a little easier. The reciprocal of 1/3, or -1/3, would simply be -3 over 1, which we know is -3. Now the tangent or cotangent, I'm sorry, is going to be negative 1 over 2 root 2, which I know I need to rationalize my denominator, right? So it's still going to be negative. I'm going to have a root 2 on the top, or in the numerator. And down here, root 2 times root 2 is 2. 2 times 2 would be 4. So I end up with negative root 2 over 4. Okay. Now, something real quick and easy. I want to find sine of 1.35 to 4 significant digits. You will notice there is no degree here. Therefore, it is implying it is a circular function or in radians. Therefore, what you need to do is set your calculator to radian mode. So you need to go to settings, and then in those settings you will need to go to radian mode for your, and they're in the general settings. I'll go through that with you in class because we're going to watch this video in class. So, and then it is quite simply, you simply type in sine of 1.35. You hit enter, and as long as you're in radian mode, you should get 0.9757. Okay, easy enough. As long as you are in radian mode. If you're not in radian mode, you're going to get the incorrect answer. Okay, move on. So now let's find the exact values of the 6 trig functions of 5 pi over 6. Now when we say exact values, that means that these must fall on one of my special triangles. Okay? So here's what I want to do. All the way around here is pi, right? So 5 pi over 6, that's 5/6 of pi. That means I'm going to be over here in quadrant 2. So let's look here real quick at what we have. We're going to be talking about this spot right here. Okay. So let's see here. Draw this arrow. Because I want for you to kind of recognize here. Talking about that as pi, or 5 pi over 6. Okay? So, when we started over here, and we went here, we're talking about this angle right here. Now, we say angle, we're talking about circular functions. We say angle because we're going to need to use these angle measures to find the values of the x and y of this point up here. If this is 5 pi over 6, I can use my calculation, my conversion, to get how many degrees that is, and I would multiply by 180 over pi, right? And when I do 180 over pi times 5 pi over 6, I get that that is equal to 150 degrees. If that's 150, what's this little angle right here? Well, you should know that it is going to be 30 degrees as soon as this stops thinking here. So 30 degrees. Okay. So now I can start thinking about, hey, I can find the value of this point right up here. Okay. Because I know one thing. I know that this radius of this unit circle is what? What did we say that radius was? We said that it is 1, right? And in a 30, 60, 90 triangle, I know the relationship between the short leg and the hypotenuse. I take the short leg times 2 to get the hypotenuse, right? Which means that the short leg is half the hypotenuse, which in this case would be half. Then what do I do to the short leg to get the long leg? short leg times root 3, if you remember, to get the long leg. So that would be root 3 over 2, because root 3 times 1/2 would be root 3 over 2. Now, when I'm giving the coordinates of this point right up here, though, my x value, I went left root 3 over 2. So is that positive or negative? I should list that as a negative root 3 over 2 for my x value. And my y value should be 1/2. That's positive. So now it should be relatively straightforward to find the sine, cosine, and tangent of all these. I've found 2 of the 3. The sine is equal to y, so the sine is simply 1/2. The cosine is equal to x, so the cosine is negative root 3 over 2. And the tangent is going to be y over x. So there'll be a little math to do here, but 1/2 over negative root 3 over 2. And if you want to skip this step and go straight to the multiplication of the reciprocal, you can. 1/2 times negative 2 over root 3, which gives me negative 2 over 2 root 3, which I need to rationalize my denominator. And when I rationalize my denominator, I should multiply. Well, you know what? I just about messed up there. Wouldn't be the first time, right? I can simplify my 2's out. I wasn't wrong by what I wrote right there, but I can simplify quicker. So negative 1 over root 3. And I will rationalize the denominator by multiplying by root 3 over root 3. So I'll end up with negative root 3 over 3, right? Okay. Now I'm not going to finish this out with the other 3 trig functions, the reciprocals. It's my thinking that you should be comfortable at this point getting the reciprocals of these. Now, for the reciprocal of cosine and reciprocal of tangent, obviously, you're going to have to rationalize the denominator again. Okay? Alright. Now, lastly, we're going to find x to 2 decimal places if the cosecant of x equals 1.077. So we're going to want to make sure that we are in radian mode, because it says it wants our answer between 0 and pi over 2. And I should know that pi over 2 represents radians. So if I'm looking for my value and I have the trig function or the circular function in there, what am I going to use? I'm going to use the inverse feature on the calculator, 1.077. And that is going to be equal to 1.19 radians. And I need to make sure that is somewhere between 0 and pi over 2 radians, and it should in fact be. So, alright, what we're going to continue to work on is, we're going to watch this in class, but you're going to continue to work on page 616. We're going to do 8 through 13. I believe those are the oral exercises, and then on page 617 we're going to do 1 through 25 odd. Alright.